For the polynomial negative 2x cubed plus 16x, find the following. First, the end behavior of the graph using the leading coefficient test. So looking at the leading term of this polynomial, just the negative 2x cubed, because it has a cube in there, it's going to follow the end behavior of the graph of x cubed. But because the leading term coefficient is negative, it's actually going to flip-flop. So normally the graph of x cubed would look like this, falling to the left and rising to the right, but negative 2x cubed flips that around, and so the end behavior is going to look like this. So this is on the left-hand side, it's rising on the left and falling on the right. So that is this answer right here. Next, we want the x-intercepts. Now, to find the x-intercepts, we're essentially looking for zeros, but in particular, it needs to be real zeros. And to find those, I think what I'll do is just take the polynomial as is, and it looks like there's a common factor that I can bring out, and I don't particularly need to go through the process using synthetic division because of that. So negative 2x can factor out of the terms and leave me with x squared minus 8. Now, x squared minus 8 is a quadratic that I can solve pretty easily. I just take x squared minus 8, set it to 0, and that will give me the remaining zeros. So x squared equals 8, or x equals plus or minus the square root of 8. And since 8 is 4 times 2, and 4 is a perfect square, I can rewrite this as plus or minus 2 square root of 2. So the x-intercepts that we have here are 0 itself, because the x here gives me a 0 of 0. And then I have positive 2 square root of 2 and negative 2 square root of 2. Now, each of these also are zeros of multiplicity 1, because there was no square term on the x's after we factored everything out. So what that means is for all of these zeros, the graph just passes through the x-axis. There's no places where the graph touches the x-axis and turns away. So those points do not exist in this graph, and at all points, the graph just passes through. Now, the last thing that we're interested in is the y-intercept. The y-intercept for any graph is located at f evaluated at 0. So in this particular case, if I plug in 0, I would have negative 2 times, since it's x cubed, it would become 0 cubed, plus 16 times 0. What happens is this results in just 0. And all that means is I have a y-intercept of 0, 0, which is the origin, and the graph is just passing through the origin.